Jai Hind to all. Myself Yogendra Prajapati, Assistant Professor in CSC Department. Today I am going to teach very important topic of the discrete structure of theory of logic. That important topic is a group theory. In this topic, we discuss about the definition of the group and some property of the group theory. Now, group theory. What is a group? Group is a mathematical structure that follow the some property on the basis of the binary operation. On the basis of the binary operation. Binary operation can be represented in the form of the star or in the form of the plus. The following four property of the group we are going to discuss. The first one is the closure property. The second one is the associative law. The third one is the identity element, and fourth one is the inverse element. If any algebraic structure or a mathematical structure follow these four property, then we can say that these algebraic structure is known as the group. For example, set of natural number. This is the mathematical structure. If that mathematical structure follow these four property on the binary operation, then we can say that a set of natural number is known as the group. First, what is the natural number? From 1, 2, 3, that is infinity. That is the set of natural number. What is the closure property? If we pick any two element from the natural number and we operate the binary operation on these two number, and the result of the operation is also belong to the natural number, then we can say that this mathematical structure follow the closure property. It means for every 2ab, that is the element of the n, and if we operate and that is also the element of n, then we can say that the set of natural number follow the closure property. It means the multiplication of the two number is also the element of the natural number. It means the set of natural number or a plus b is also the natural number. It means we can say that the set of natural number follow the closure property. Now, next one is known as the associative law. Associative law is the testing of the next phase. In closure property, we operate the two element. In associative law, we operate, we are testing three element. For every three element, if we operate the binary operation, then the result of that operation is also belong to the in the same set, then we can say that this mathematical structure is known as the group. Now, for every a, b, c is element of n, then a into b into c if also belong to the n, then we can say that is follow the associative law. This one, or a into b into c, this is also belong to the n, and both are equal, then it is follow the associative law. If any mathematical structure follow the first two property, then we can say that for these two we can say that that mathematical structure is known as the semi group. It means first two property, it is kind of the testing of the closure operation. Now the third property, we can know that the identity element, that is the main element of the any algebraic structure. With the help of the identity element, we can access the overall the mathematical structure. Now in mathematical form, what is the mathematical structure? What is the identity element? That is the very simple definition of the identity element. If for every operate an element and the result are same, then this element is known as the identity element. There are the two type of the operation, plus operation and multiplication operation, that is known as the binary operation. It means by default any mathematical structure for the multiplication operation, identity element is always 1, and for the plus operation, identity element always 0, and these two is also the belong to the same set, then we can say that that algebraic structure follow the first three property are identity property. It means 1 is also the element of the n, but 0 is not the element of the n. It means for this operation, natural number follow the identity property. For the plus operation, set of natural number does not follow the identity property. If any mathematical structure follow the first three property, then we can say that that mathematical structure is known as the monad group. First two property, semi group. First three property, monad group, and that is the property of the identity element, this one. Now the if fourth property is known as the inverse property. If any mathematical structure follow the inverse property, then we can say that this mathematical structure is known as the group. What is the property of the mathematical structure? A operation B, if we find the E is identity and A is element and B is also element. If such kind of the value, then we can say that B is inverse of A and B is also belong to the same set, then we can say that that mathematical structure follow the inverse property. If any mathematical structure follow these four property, then we can say that that mathematical structure is known as the group. It means set of natural number for the multiplication operation is monad group. Set of integer, a set of real number for the binary operation is known as the group, because inverse property is also followed, identity element is also followed, associative law and closure property is also followed. So these are the basic definition of the group by which we can explain all the mathematical concepts. Now we move from the very important property of the group. The identity element of a group is unique. How can you prove that the identity element is unique, it means we take a two different identity, E1 and E2, and we prove that if E1 is equal to E2, then we can say that the identity element of a group is unique, or E1, E2, E3 with three different identity. If we prove that E1, E2 and E2, E3, these three are equal, then we can say that the identity element of a group is unique. Now, according to the property of the group, A into E1, that is A, the first identity, and A in A operate E2, that is also known as the A. E1, E2 are two identity of a same group. Then we operate in any element where A is element of a set. Now, if we assume that E1 is element and E2 is identity, then we can say that E1. This is another same property, but we follow these, one is a element and one is the identity. Similarly, E2 and identity is E1, then it is known as the E2. For these two equation, we can say that E1 is equal to E2. That is very simple. It means the identity of the group is unique. Okay. Now we move from the another important property of the group. That is the inverse element of a group is also the unique. We follow the same approach. We assume the two different inverse of the group, and suppose A1 and A2, these are the two inverse, and if A1 is equal to A2, then we can say that this is the second property, then we can say that the inverse element of a group is a unique. Now, A into A1 is equal to E. That is the property of the group. And A into A2 is equal to, that is also a E. It means A into A1 and A into A2, and this one cancel. It means A1 is equal to A2. We can prove that the inverse element of a group is unique. First, we take the two different inverse and follow the property of the inverse, and using the mathematical concept, we can prove that A1 is equal to A2. Then we can say that the inverse of the group is unique. Now, that is the also the most important property of the group. A inverse, that is, we prove the A. Okay, we follow the property of the group. Now, A into A inverse or A inverse A, that is, we know that the E. According the property of the inverse property of the group, we can write this one. Assume that this is the inverse element. We take A inverse and A inverse. in this side we take the inverse element. Now here the inverse element. Now in this side A inverse and A. Now using the left cancellation, this one is cancelled. It means A inverse, that is A, this is we can prove. This is the also the most important property of the group. A inverse of inverse is known as the group, and with the property of the inverse property of the group we can prove this one. This is the also most important property asked many times in the university examination. This question, this property of the group is also important. Many times asked in the university examination. This is also known as the left cancellation law or the right cancellation law. What is the A operation B, A operation C? If these two statements equal, then we can prove that B is equal to C. In this equation, we multiply the A inverse on both sides. It means A inverse A into B is equal to A inverse A into C. Now A inverse, what is the inverse property of the group? A inverse A, that is E. It means we write here E into B, same E into C. And what is the identity property of the group? Identity property of the group, A into E is equal to A. For this concept we can write here is a B, now this side here is a C. Now this is the proof. This is also known as the left cancellation law. This is the proof with the two property of the group. The first one is the inverse property and the second one is the identity property. Similarly, that is the right cancellation law. Right cancellation law, we can also prove the property of the group, that is two property, inverse property and the identity property. Here is A into C and B into C. Now A is equal to B. For this A is equal to B. It means we multiply both sides C inverse. Now A into C inverse into C. Here is also B into C into C inverse. According to this property, we can write A into E. Here we write B into E. And according to the identity property, we write A is equal to B. So these are the very simple property of the group. We can prove by the help of the identity and inverse property of the group. Now these are the two another example we are going to discuss. A inverse is equal to B if only if B inverse A. Now we are taking the first one, A inverse B, and we taking the inverse of the both side. It means A inverse we write the B inverse. And in previous property this one we can write A inverse of inverse, we can write A. It means here we write the A. The first one is clear. Now we check the another example, B inverse A, same procedure. It means B inverse A, we simply take the B inverse, that is A inverse, or here we write now this one and this one, that is the also most important property of the group, and we are taking the very simple property of the group. We can prove that this one and this one. We move another property of the group, that is A operation B inverse is equal to B inverse and A inverse. Now taking the A B inverse, that is B inverse and A inverse, and according to the property of the group we can multiply by E A into B inverse, and here is a B inverse A inverse, and we write here E A into B, B inverse and A inverse, and this value we multiply into the this time. So now E is equal to B inverse into B, A inverse into A. According to the property of the group, this one is known as the E and this one is also known as the E. It means E operate E, E operate E, and here E is equal to E. So this one is proof. Here we are going to show the main 6 property of the group, and in university examination every year asks any 2 property. So we meet the some important topics of the group in next lecture. Thank you.